Get into screen share mode, screen show mode. Great.
We can start with the presentation. The timer would start now.
Perfect. So I will talk about my company later towards the end of it. I first wanted to speak about, the problem that we are trying to solve here, right? And the main problem that we're really seeing is, listen, data-driven decision making. When you want to do that in corporate settings, specifically in business settings, it takes too long and too much effort, right? I think at this point in time, if you talk to any practicing people, the typical lead times are 6 to 9 months. That's what everybody says. Uh, Let me just a minute. Yeah, that's what people say is going to take, right? And that's pretty much the current time. So what we're saying is, can we do something about it? Can we make it much faster? And then when you look a little deeper in terms of what exactly is happening, well, you have the raw data. The data scientists have to do a lot of work on that. Prepare the data, shortlist patterns, build and test hypotheses, build predictive models. And on top of that, there's the business involvement out there. The data scientists go give all these insights to the business teams, but then the business teams come back saying, hey, this is relevant, this is not relevant, this is actionable, this is not actionable. Can you build new models? Now that gets into a fairly iterative cyclical structure out there. Now, and if I were to do the current way, right, doing the current way, the data scientist goes, presents, and then they say, hey, can you try this? Can you try that? And it ends up saying, okay, we will do that. Let us schedule another meeting sometime later. And then sometime later, everybody again gets into the scheduling mess ups. It does take a lot of time. Now, we are looking at in terms of the end-to-end process, not just the model building process, but from the time you start thinking about idea and data to the time that you kind of can deploy that on the inside the business. So can we do that entire thing? And on top of this is a whole bunch of constraints. It is not easy, right? There's a whole bunch of constraints. Things like, things need to happen fast, right? Otherwise, the world will change. The model, if you're still working with 6-month-old data, it might not even be relevant now. So you got to move fast on that. Uh, and then context, everything has to sit in the context. And that pretty much is what we are trying to solve here, Peter and Kun. And that is pretty much what we built Zuno Predict, right? What we're trying to do here is two things. One, we're trying to automate the entire thing that a data scientist typically does. When we say automate, it isn't as if one clicks here and goes all there. All these little steps are automated, right? But you can get in and get out at any point in time, whether it comes to building in the business understanding, data prep, EDA, feature engineering, all of that, right? All of that we are trying to automate there in terms of the process. I think the other big thing that I also wanted to point out is because we are right from the beginning, we are thinking in terms of how do we deploy this? How do we ensure this is integrated into the business context? We're building everything API based, right? So that, it can easily go set into whatever the environment that the users, my users, which are business users are in, right? And in terms of the innovations, right, there are, because we're looking at the holistic view, we're looking at, not just the modeling part of it, we're looking at the full process. So one is we are trying to accelerate problem solving via the hypothesis discovery part of it. We have some really cool innovations. I will talk about that in the next slide in terms of what exactly is happening there, right? Signal factory, which is really our key stuff that is happening, signal factory and signal filter. The second thing really is on all the ancillary work that happens, which is before model building, you do a lot of work in terms of cleaning up the data, preparing the data, EDA and all of that. So we have a nice tool where you can, where all that kind of comes up automatically and people can keep looking at that. The second part is you have a great model, you finalize a great model. What do you do about that now? You still got to use that. So everything comes in terms of, charts and API endpoints. Every model has an API endpoint so that, things can easily get integrated. And finally, we have also have recipes and macros, because what we've also noticed is in a business context, typically if I were to go to one particular company, they tend to have the same kind of data format, the same kind of pipelining, So we keep saying, hey, can we automate this? Can they do it one time and then save that work? Anytime new data comes in, they can just look at it as a macro and move on, right? So that is the last piece that we're seeing. As I said, everything we are looking at, can I really crunch the full process, right? Not just the model building part of it, but the full process. Now, a little bit more in terms of the really core algorithmic part of it that we are doing. Now, one of the big opinions that we have, right, is really that, this is a business context. So, what the hypothesis will matter a lot more than the model building part of it is, just the model building part. The data, at least the customers that we work with, they work with, in their world, it is large data, but these days, computationally, it is not that big. So we spend a lot of time on what we call signal factory, where you're really saying, hey, what should go into the model? If you were to start with an analyst saying, a data scientist saying, hey, what do you think are the more important things here? They will start off with saying, hey, on the left box, that all the hypotheses, they'll make a list of hypotheses saying this is important, that is important, so on and so forth. And they will go ahead and test that. But what we really realized is the big things, but then the business people come back and say, hey, listen, but we already knew that. Or it is still useful, we can still automate it, but it almost always is we already knew that. So, and that ends up being quite underwhelming. The big value tends to lie in the orange box here, right? And to get there, we have what we call the signal factory. What we really say is, and this is very interesting, right? The origin stories of it, where we said we want to automate this. We want to automate the hypothesis creation part of it also. So we said, okay, let me list down, is it even possible? We said, let me list down 15, 20 different industries and problems there, and start looking at what are the important hypotheses there. And then start looking at, what are the mathematical formulations behind that, right? And what we realized is there's a lot of commonalities. To just give an example, if I'm doing an e-commerce thing, hey, should I show a toothpaste ad to Swarna? Now, the most intuitive thing one would look at is how frequently would he be buying, the frequency thing, and when did he last buy, recency. Just look at frequency, which is, that let's just park it for the moment, frequency. And if you were to do predictive maintenance in a factory floor, the first thing that they would be looking at is MTBF, mean time between failures. Now, if you were to look at the mathematical formulation of it, they're exactly the same. If I were to write a SQL query, it'll pretty much be the same, right? Just the inputs will change. And that really was our insight there. Oh, okay. Now the universe isn't that large. At least when I restrict myself to the business world, I can just start building all of them then. So we said, okay, let's not have any biases. Let's have what we call the signal factory. Let's just create all the signals. Let's just create all of them. And then let the machine figure out what is important, what is not important. And that is a signal filter part of it. The first one needs a lot of computational optimization. The second one is more algorithmic. A lot of triangulation is happening there. Some of them is coming from papers and some of them is just our experience there. There we're saying, oh, we built all of them. On the chart here, I showed nice, clean, equal boxes, but then most of them will be junk. We know that most of them will be junk simply because we're building from anywhere and everywhere. So that is where the signal filter comes in. And all this entire thing happens pretty much automatically. And that is not enough, right? Because that's the first thing that will come up. And then the user will say, hey, but why did you do this? Why did you not do that? Right? And there's a lot of domain expertise that comes in. And I talked a little bit earlier in the top of the call in terms of the iterative framework and a lot of iterations happening. And that's the other thing that we already built into the tool, right? Zuno.predict, point and click, you can say this is interesting, this is not interesting, just keep doing it, and we can kind of move from there. Now I'm really rushing through because my eyes are also on the clock there. Uh, and yeah, and I would love to show you a demo if there is time. Maybe I will do that. But before I do that, just an example of a churn use case that we just finished with a client of ours. A lot of data sources. The entire modeling we finished in like a few days, nearly 100 models with a lot of iterations. There's some examples of, you can see a lot of models that are done. If you look at the timestamps are really close. On the right side is really the kind of features that get built, as well as, the iterative stuff, right? Where you can say, hey, you can do this, you can stop, injecting feedback. And these are some examples of what we have done in the past. And I think the main thing is, A, things are happening really fast. And B, the approach seems to be working across industries, right? Across industries and across problem statements. And that there's a couple more slides, but I think I will stop here for any questions, given that my time is also up. And I would love to show you the demo also if there is time for that.
Thank you, Swarna. Judas, we open for questions. Yeah, Professor Peter, you have a question.
Yes, so unfortunately, we didn't get to the demo. I was waiting for this. So at which TRL are you operating at the moment? Technology readiness level?
We would be rather high at this point in time, Peter, right? We are a tech company, right? We are a software company. Now, I did not talk to you about the company in itself, right? So we are what we call a practical AI company and building practical AI solutions, right? Now, what we realized is there are several ways in which you can, several paradigms that are happening there really. One way is on data-driven decision making, which is where Zuno Predict comes into play. We are also seeing a lot of other use cases around automation, productivity automation, which is where we are doing quite a bit around
So would
generative.
you be able to give sorry that I'm interrupting you, but I'm not getting the answer to the question that I actually asked. So can you give a number on the TR level? You said pretty high. What does it mean?
Actually, okay, let me just admit this, right? So I do not know the framework that you're using for technology, how advanced we are. So all I know is I would imagine we are very high. I do not know the answer to that, Peter.
Okay, so is this being deployed and used at
Oh
the
yeah,
moment by some
absolutely.
companies?
Absolutely. We are having several customers. This is being used in production right now, Peter.
Okay, and could you at least maybe in words describe the most successful deployment, how it works, why it works, and so on?
So okay, let me take a minute there then, right? So we just finished up a use case where this was a $600 million SaaS company, $600 million ARR, right? And the question really was, hey, my customers are churning out. Can you tell me why? And can you give me advance notice? And they wanted 4 months advance notice, right? Now, it's not as if they don't have a solution. They already have a churn solution. They already have a predictive solution. And their big question was, it doesn't seem to be working. Can you do something about it? They had several sources of data. And one of the things about sources of, okay, finance data from NetSuite, product telemetry from Pendo, Salesforce data, and customer success tickets data from Zendesk, right? Now, each of them is owned separately by their respective departments. The standard organizational problem. Now, using Zuno, what had happened was they just put all that data together and put it into Zuno, right? Now, Zuno automatically did cross-source comparisons, and it figured out all the hypotheses that were important across sources, right? And built models. And we did several iterations of the models. I'm just talking about the model building process right now. I'll talk about the results shortly also there, Peter, right? Now, we built nearly 100 models. We started off with one model for all the products, but then what we realized was, hey, some products behave differently. Actually, Zuno was also showing that. So it made more sense to build separate models. And we did several iterations, about 100 models in about 2 or 3 days, right? Because we were just iterating there. And we finally chose the model and we deployed it. Now, after
Now you say
deployment,
that you chose it and you deployed it. So which part was automatic here and which part was not?
okay.
Because you said everything is automatic, but now you say first there was a model, then later there was some other models. How is
Perfect.
all of this
Great.
working?
Great, great. The first model was automatic, right? You just give the inputs. The first model was automatic. After that, as I was saying a little while back, right? They will come and say, hey, can you drop this variable? This signal doesn't make sense to me. or this doesn't exist anymore, or I know how this particular data was computed. Can you change that, right? Or can you make separate models for each product? Now, all that is part of the demo, all that is part of the tool per se, Peter, right? It is all point and click, say, drop all of this or subset the data by that, right? All that is part of the demo, right? Now, that obviously was not a automatic process, right? In the sense that they would give the input, we would put the inputs there and again say click, and again it would build the model, it would generate the model again.
So I'm satisfied with the answer. I want to give time to others because already I took too much of your time. Thank you.
Thanks, Peter. Yes, sir.
Okay. Thank you for the presentation. So at a high level, I think the idea is pretty clear. However, at the same time, I'm not very sure about innovation uniqueness and market impact because I didn't really see the details. For instance, can you just say a bit more about the hypothesis generation, right? What kind of hypothesis are you referring to, and how could you really make it automated? And yeah, one kind of very concrete example regarding use case, right, would be very useful. Thank
Perfect.
you.
So let me take a different use case. I've just finished up another forecasting use case, right? This is inventory for inventory. I'm doing sales forecasting for inventory management. Now, they just gave us a bit of data. Zuno, the only input to Zuno.
Kumar, it would be nice if you don't tell a story. Give the response to the point. Right? Because you're giving the answers here and there. Give the pointed answers.
So I think context would be a little useful here, no? And that is the reason, so that if they understand that, because they ask for an exact example. So here it is really about inventory, right? Now, one of the features in the raw data was, distribute an inventory. And another feature was, amount of pending sales. A third feature was POs that they had. Now, from the hypothesis standpoint, it automatically started going and building, hey, in this product family, what was the standard inventory in the past 3 months? And how does inventory now compare with the past 3 months trend? Why 3 months? It also did 1 month, it also did 6 months, it also did 12 months. And not just for inventory, it did a similar thing for PO quantity. It also did a similar thing for all the other features that other signals that you had in the data, Professor Zhang. Right? This is one example of it. Some other yeah. So any questions, or you want me to elaborate or take some other examples there?
Oh, that's good. Thank you very much for answering the question. I think others may have other questions, so I will stop here. Thank you.
Yeah. So Arna Kumar, I think the questions are similar. What he asked earlier. It's still not very clear. Now, suppose you have let us say 100 variables in the system, right? How would this hypothesis generation happen? I mean, is it a standard algorithm which says that per feature, I will ask a specific set of questions and that you call as a hypothesis, and then you try to run statistical tests on it either to prove or disprove the hypothesis? What is the innovation in hypothesis generation is what is not very clear to me. Okay. Based on your description right now, my understanding is that it's a deterministic algorithm where given a set of features, it will do certain set of standard checks. And based on that, it will generate the hypothesis. Like you said, it may generate hundreds of hypotheses. That leads me to believe that it's a deterministic algorithm. Okay. So please explain what is the innovation in the hypothesis generation and the hypothesis filtering, because that seems to be the crux of the matter of this whole innovation.
So I think that's a great question, Professor Kulkarni. And on the hypothesis generation part, I would agree with you that it is a deterministic process.
Okay.
It is that. It is a deterministic process. I think the main innovation there, if I were to think about that, would be to be able to generate thousands of hypotheses in an extremely short time. Here, extremely short time would be a matter of a few minutes on and very standard hardware, right? Working with that large data, right? I think that is going to be the main thing. And we had to do quite a bit of work to get it happen in more real time, right? Because we want fast iterations. So yes, so that's on the signal factory part of it. The algorithmic innovations, and that's a set of innovations which are really around the filtering process there, right? Where now I have 5,000 hypotheses. Now, intuitively, I would imagine a lot of them would be not particularly useful because it's a very standard approach, as you already figured out, right? It is that. I mean, I'm not going to go anywhere with that, right? But the question then becomes, how do I figure out the right subsets, not even single features, but right subset of features, which will come in and say, hey, this set of features together will explain your target variable the best. There, I think that is where the algorithmic stuff comes in, and that is what it is there, sir. I'm looking at the clock there. Yeah.
Okay. Okay.
Still, we could not really get any answer that where is the innovation, what kind of innovation you have done. Anyway, the time is over. It would have been nice if you could have highlighted what is your core innovation, since this is an innovation award. Thank you so much.
Thanks a lot for the feedback, sir. Thanks a lot.
Thank
Bye.
you. Thank you, Swan. Thank you for
Thank
attending.
you.
Swan, I'm just sending you a link in the chat box. Please do copy the link before we leave the session.